Same, okay. All right, so let's think about that again. So the line in three-dimensional space either intersect perfectly, will be parallel, obviously not intersecting, but it'll have the same direction vector. Will be coincidence on top of each other, so they would share all the same points and also have the same direction vector, or they'll miss. And that's skew. So they're off. So you could find the intersect, it's like, so we're going to be looking at angles between two vectors. So if they cross over, that's not too bad, because you know where they cross, and you can use that. You can use your dot product and your magnitudes and that cosine theta. But can you find the angle between two that are skew? No. You can think about it as a bridge over a road versus two roads intersecting. So the bridge over the road and the road, you can still find an angle between it if you kind of think about where if you moved one down, you could find the intersection. So you can find not the intersection. You can find the angle between them, even though they're not intersecting, but you can move this one, almost translate it down so it does, and it would have the same angle, yeah? Even though it's skewed, even though they miss. Yeah.
When they're intersecting, you find like K and T, because there's two equations and then you...
Okay, well, yeah, let's talk about intersection and find them. Okay, that's just what that says. It's the same thing. Okay, so let's look at an example. We have three lines, and we want to show that, figure out, are they parallel, are they coincidence, are they intersecting, are they skew? So we're going to look at these three lines. Line 1, they're in parametric form, which is useful. This is my first line. Let's look at my second line. Well, this is what we need to think about. If you're thinking about, okay, are two lines parallel, direction vector will definitely tell us are the two lines parallel. And we'll show how to do that. So we're looking at this third line, and we're looking at the relationship between all three of these lines. Okay, so we're looking at line 1 and line 2 first, and we're trying to figure out, all right, what relationship do these two have to each other? Let's look at, if I want to figure out if they're parallel, coincident, intersecting, or skew, having a good look at the direction vector would be a good place to start. So what's the direction vector of line 1? So we're looking at line 1 versus line 2. So line 1 has a direction vector. Oh, I have S's and T's here. I've mixed them up. This one has to have an S, not a T. So 2, taken here, 2, -2, and 4. You happy with that? 2, -2, and 4. So that's line 1's direction vector. We got that from, if you rewrite this as x, y, z, the first point is -1, 1, 1, plus s times 2, -2, and 4. So just that's the other way. So this is the position, and this is direction. Okay, so what's line 2 then? Flane, you've got it already? -1, 1, and -2. Okay, so how do I say 1 is if it's parallel or not?
Oh, because S and T are multiples of each other.
No, that doesn't prove it.
Yeah, so if one, we can multiply one of them by a scalar. Yeah, so if I multiply this one by -2, I get that one. So k is equal to -2. So it is parallel. It is parallel.
So just write L1 and L2 have a scalar multiple between their directional vectors, so they're parallel?
You can write that, yeah. Yeah, scalar multiple. And you can say what it is as well. K is -2. All right. So now we have to figure out, are they coincidence? Now we know they're parallel, but that doesn't mean they're coincident. They're the same line. So how do we show that they're, it says in the question that they're not coincident, but how do we figure it out? Yeah, we need to compare a point. A coincidence would mean all the points along it are the same. So if we can find 2 points that are different, that would help. So let's look. So this is line 1 over here. Line 2, if you want to rewrite it in this form, is 1, 0, and 3, plus t times minus 1, 1, and minus 2. Okay.
What? Oh,
Yeah, so I've just written this line as one of these as well. Okay. So what point will we pick? So I want to see there's a lineup. As the position vector here, minus 1, 1, 1, these are all different, 1, 0, 3. So you can't compare those 2 points. So you need to compare a point where at least one of the coordinates is at the same.
Say, like, you would take the first point for line 1, the negative 1, 1, 1.
Okay.
And try x equals negative 1 for line 2.
Okay, so we take this point and we see, let's match up.
Yeah.
So
Say negative 1 for
I think we have to pick a value for t here to find another point on this line, because this one's not working for us because they're all different. What would be an easy,
t equals 2.
t is equal to 2, which one will that give a comparison for?
X equals negative 1.
I think if t is just 1,
Is it negative?
How did you get t?
Yeah, you know what, that also makes sense. That is
if
correct.
t is 1, I'll get y to be 1, won't I?
That's also
Which is the same y coordinate as this, which means the other two should be the same if they're coincident. If they're different, they're just parallel. They're different, yeah. So
1, 2, 1, 0, 1.
when t is 1, we get this point out of this line. It goes through, it does go through 1 on the y, which is comparable, but what about the other ones? 1 plus, so 0, isn't it? And 3 plus, 3 minus 2 is 1. Pretty close. Pretty close, but we have this x coordinate problem. So they are just parallel. You can see the x is different on each line. One sits above the other. Okay, so they are not coincidence, they are just parallel. Second task, let's look at line 2 and line 3. We have to show that they intersect, so we don't even need to explore if they're parallel or not, so we don't need to look at the direction vector. We're looking at line 2 and line 3 and show that they intersect and find the angle that they intersect at. Yes, sir.
How did you prove that they're not coincident? Because when t is 1, y is equal, the y's are equal, but then x and z aren't equal?
Well, z
Yeah.
is equal, but x is not.
It should create the same. So these are two different positions.
Yes. And so.
But if they're coincidents on the same line, they should be the same position. They should sit on top of each other, the same position. But this one, they're not sitting on top. There's one, all the x's and z's, or y's and z's are the same, but the x's
The y's
is,
and z's are the same.
yeah, but we didn't get the same x. We expect the same point in the same position.
That means it's just like right above it.
Yeah, it's sitting above it. Well, yes, which is, yeah, what we expect. Hmm?
So is it y plus 2? Oh wait, how do you make it?
I just lined up the y points. So I know that this, so s is 0 here pretty much. I said s is 0 in this one to get this point. And then I said, oh, right, make t 1. And how does that affect my point? Why did I do that? Because, so I did, to find the x coordinate, I did 1 plus 1 times minus 1, and that gives 0. And y just was 1, because of 1 times 1, and there's no, and that's the one I was looking at comparing. Well, that's the same. I get the same here, but I don't get the same for x. So they're coincident. So they're parallel, not coincident.
So you just choose a value for t.
Yes, I choose a value for s and t, yeah. So they line up, one of the coordinates lines up the same. Because then the whole point should be the same. If they're coincident, the whole point will be the same.
Yeah, it's 3 plus minus 2, 4 plus minus 2. How come you changed line 2 to minus 2? I thought that was supposed to be 1.
Line 2 is minus 2. Line 2, is that not line 2?
Because when you include the S or the T, that's the velocity vector.
So our S and T
But
both
I
are.
could like just denotes which way it's going.
S is 0.
S is 0.
S is 0. I just took this.
Yeah, because
It's the easiest one. I could have taken this and said T was 0 and then find one for S. I could have done the same thing and I would have got some that are the same coordinate, but
you would get line D to be about the same thing.
yeah, X would be different. Okay? Hmm? So I'm just picking so that Y's match, the Y's match. I didn't look even at the Z's, I just looked for the Y's to match. Because when there's a Y coordinate. Do you want me to do it again, maybe?
No, I think.
Oh, we have more examples coming up. Maybe you'll do a few in a minute and then you might get the hang of it. Okay.
It's just like finding like points that are the same.
Yes. Yes.
But if they don't exist, then it's not coincident.
Yeah, it's like the X, the Y.
Let's find
One
one
way
way
Yeah.
where it is.
It's like the Y point had both the same value, so we're just seeing, does the X point have the same value at the same place? Oh no, one sits above the other, so that they're not the same. Okay, let's do line 2 and line 3. Show that they intersect. So to show they intersect, they should have a point in common where they cross over. So we let the X's equal X, the Y's equal Y, and so on. So let's do that. The X is equal, so these two should be equal. 1 minus T should equal 1 plus 2U where it intersects. The Y should equal as well. T is equal to minus 1 minus U. And the Z, we might even need the Z's, but we'll let them equal anyway. 4 plus. Because there's only two variables here. So we don't need the third equation, probably.
That's true, yeah.
Okay. So a quick rearrangement here, maybe substitution. I'm going to sub this in for this T, maybe. I don't know if that's the easiest way to do it. 1 minus 1 minus U is equal to 1 plus 2U. So I should get an equation out of this. 1 minus minus 1 is 2, and 1 minus minus U is plus U. So I get 2 plus U, I think, out of this. Just make sure I've done that right.
Well, isn't it 1 minus minus 1 minus U? So it's just 2 minus U?
No, you're subtracting a negative U as well.
Oh, you put it in brackets.
I did, yes. So the T has to be replaced by it. All right, and I've got 2U over here and 1. Bring everything together. I think that gives a 1 and a U. U is equal to 1. I subtract U and subtract 1. I put sub this in for this T. I saw Dylan's look. Yeah. Yeah.
Minus 2.
Okay, sub that in. Okay, so if U is 1, what is T?
T is minus 2.
I think T is good.
And then what do you use?
What I do?
You sum
I
it.
got this and I subbed it in here
You sum it in.
to solve. I solved substitution, not elimination. So if U is 1, then I can say that T is negative 2 because I have that relationship. Okay, so I got U and I got T. That's not giving me a point.
You solve the parametric equations.
I didn't even need to get T, did I? Because I was just looking for the point of intersection.
Yeah, you would just, that's came up like last class. You can just sub U into all of the other ones. 'Cause
Okay.
it's equal.
Okay.
3 minus 2 is 7. 3 minus 2 is 7.
I think if we're showing that, I think we probably should show us the same point on each line.
Yeah, that's true.
It's
yeah.
correct.
It's better to be.
So this is line 1 and 2 over here. Let's look at line 2 and 3.
But if you know they're parallel, then
The point on line 2, line 2 point would be when T is negative 2. So I have to work out all these coordinates. 1 minus minus 2, 3.
It's 3 minus 2.
Minus 2, thank you. Positive 7, yeah? Yes. And the line 3 point, so I'm just subbing in now 1 for you. That'd be easier. 3, minus 2, and 7. Yes, okay. We've shown it. They cross at the same point.
Find the angle between them.
All right, so we need to find an angle between them.
Product.
Yes, angle between them is we're always looking at,
The directional vectors, V and W are the directional vectors.
yeah, direction. So we're looking at V dot W all over V, the two magnitudes. So we're looking at the, let's pull out the direction vectors out of both these. Line 2, line 3. The direction vector of line 2 is something we had already, yes. What is it?
It's like -9.
Minus, line 2, minus 1, 0, minus 2. Line 3 then, the direction vector 2, minus 1, and 3. Are you happy with that? No? Maybe?
I think the direction vector is -1, 1, and 2.
Minus 1, 0, minus 2, no?
Minus
Sir,
1, 1,
that's-
minus
That's the point.
T. That says T, not 1.
That's his T.
Well, no, it's T times 1 is 1.
Yeah, but then it's 1, but he's saying.
Oh, 1, yeah, sorry. 1, 1, 1, 1, 1, 1, 1. Yes, my bad. That's 1. Yes.
-9 over.
I had the wrong direction here.
Do you know the answer?
Yes.
Is
Did-
it 10.9?
Yes. Okay. So if we do the dot product, which you should be pretty quick at by now, minus 2, minus 1, minus 6, all over magnitudes, which are the square root of 1, 1, and
Yeah, right. First one is minus 20.
Yeah. Wouldn't, if you had the -9 there, it'd be like.
yeah. So you have to. It's absolute value. Yeah.
But you have to 180.
You're gonna find. You want to find the acute one, not the obtuse one.
Technically speaking, it's correct, but like, it doesn't, it's not.
4,
Absolute.
5, 9, 14. All right. And if you inverse cosine that, whatever that is it 9 over root?
-9 over.
Yeah, but it's absolute value.
Yeah.
You should get 10.9 degrees.
Wait, it's on top, it's always absolute.
Yes,
value?
always. Yes, yes.
I've been doing it wrong,
Okay.
man. I've been doing it wrong.
Okay, well, it's in your formula booklet anyway, so.
It's not in the formula booklet like that.
It's in a formula booklet like this, isn't it? They have it. Oh yeah, they have it. Yeah, they don't have it. Anyway, you'll know if you get the obtuse angle. They're looking for the acute.
Yeah, it would be greater than 90.
All right, so this is kind of the same stuff. How do we show that line 1 and 3 are skew then? How do we show they miss each other?
Do we do what we did in the first one?
Will we do the second one?
That's that.
We need to do a combination. We need to make sure they're not parallel, and we make sure they don't have a point of intersection. So to show they're skew, we have to make sure they're not parallel and they do not have a point of intersection. Line 1 versus line 3. So let's look at the direction vector of both to make sure they're not parallel. So line 1 has 2, minus 2, 4. Line 3 is 2, minus 1, 3. Yeah, so you'd have to multiply by, no, there's nothing. There's nothing, no scalar product of either way.
Because one of them's already the same.
Yes, so it'd have to be 1. It'd have to be 1, and that doesn't work. Okay, so there is no k multiplier. Okay, so not parallel.
And then you would do the thing again.
And now it's to do the thing. And what are we expecting to get?
I don't know, I forget how you're supposed to like prove that two systems of equations are not equal.
Okay, so let's look at these two and let them equal each other like we had before. I'll remove this.
So you guys some Y's
Do all of them.
there? All of them?
Line, just see what, and then we have a look at which one I want to solve for. 1 plus 2u, 1 minus 2s is equal to minus 1 minus u. So we're doing these.
Why are we doing them?
It's
Wait, what line?
they're not
yeah. We're trying to find We're trying to hopefully find a point of intersection.
Hopefully not, sir.
Well, I know they said show that, but
The question implies that we don't want to.
yes,
Well, we're trying to find.
yeah. If we find a point of intersection, there's something wrong with the question,
I
isn't
would
there?
hope not, so.
Well, either there's something wrong with the question or there's something wrong with us.
I won't answer that.
It's a real question.
Okay, let's. I don't know. Well, maybe you prefer elimination. I think substitution might be easier again if we rearrange this one, maybe, or this one.
I'm gonna stick with elimination.
You can stick with. All right, we tidied up. Stick with elimination. So we get 2s minus 2u is equal to 2 from this one. 2s. Okay, and then I take this one maybe as my next one, and I have minus 2s plus u. Actually, it will be easier to do this way. Is equal to minus 2. Solve. Yeah, minus u is equal to 0. Okay. Well, u can be 0. Could it? Well, that.
Let's test it for s.
Yes.
Yeah.
Okay. So if u is 0, that means for this, even take the last one maybe because it's all positive. 4s is equal to 4 plus 3 times 0. We get an answer for s here. That's gone. 4s is equal to 3.
And then we sub them into an equation.
So you could say s is 3 over 4. So they're saying these are the parameters that it meets.
And then you would do 2s minus 2u or minus 2s plus u and see if they equal minus 2 or 2.
Yeah.
Yeah.
You put them in.
Okay, let's have a little look. Do we-
Minus 3 over 4 plus 0 is not equal to negative 2 at all.
Yeah, you could test.
Wait, sorry, minus 6 over 4, which makes no difference.
What?
I did minus 2s plus u equals minus 2.
Okay, yeah, let's.
Does that mean that there's skew?
Before I.
I can't find it.
We're trying to say they are skew.
Yeah, that's the question.
So let's just make sure these work in another one of these equations before we start subbing them in to find the imaginary point of intersection. I just want to make sure. Minus 1 plus 2 times 3/4 is equal to 1 plus 2 times 0. We're in trouble here. Minus 1 plus, is that 3 over 2 is equal to 1? So we're just getting contradictions here.
No, I think that works properly.
Minus 4 equals 0, so that's goaded. Oh, that's minus
That one's not weird.
So it's saying half is equal to 1.
No.
We could say that minus 3 over 2 plus 0 is equal to negative 2.
So it doesn't work.
Yeah.
It doesn't work for this one. If you sub it back in, it doesn't work. Finding this other one. So you're getting contradictions here. You got a contradiction. That's straight up a contradiction. So, yes. There is no inequality. There's no equality between them. So it came here when there was a 0 case, which is a bit like system of linear equations. And then you have to go on to see if they're what's it saying. Okay, so we got nonsense here, so therefore no intersection. Otherwise, we would have got something that everything was sweet here, and then we subbed it into the lines. We would also find that we kept the same point, which is what we wanted. So if there's no intersection and they weren't parallel, which we proved at the start, that means they are skew.
Sir, this is more of a logic question. If we
Yeah.
know that 2 and 3 intersect and then 1 and 2 are parallel, does that prove that 1 and 3 are skew, or is it still possible that they could intersect, just hypothetically?
Oh, you're making me think now. If line 1 and 2 are parallel and 2 and 3 intersect,
Logically speaking, since
Oh,
there's only
yeah.
one answer
Yeah,
to 2
yeah.
and 3,
yeah, you could have logicked
one
that
would
out.
not hit that,
Yeah.
and so it would obviously be
Yeah.
Obviously, the question is not asking us to do that. I'm just like saying, just out of curiosity.
Aw.
All right, here's a bunch. For each question, though, there's just 2. There's not 3. So you just have 2 to work with.
So bad.
Yeah, you just have, it's actually easier than this one. So you're only given 2, and then you have to figure out, are they parallel, intersecting, coincident, or skew?
But it's still ugly.
It's still pretty ugly. So I would probably start with parallel. If they are parallel, test for coincidence. If they're not parallel, you test for intersection. If there's no point of intersection, they must be skew. So skew is the last one.
What are we supposed to get the acute angle?
If
If-
it's very
If it asks for the angle.
No. If they're intersecting, we get
Sorry.
the angle between them.
When
Like we
they're
did.
intersecting.
Well, oh no, it does say, yeah, okay.
I can tell you the acute angle if they're parallel or coincident would be 0.
Yes, very good. Okay, so get started. Let's do A. Start. I would always test for parallel first. Test for parallel, which is pretty straightforward. You probably read that straight off it, but